Yeah, hi. Welcome to Lesson 3, Understanding Addition of Integers. This is, again, Lesson 3 in our study of rational numbers, and that's in Module 2. Okay. This first thing that it says here, this first exercise, Exercise 1, says addition using the integer game. Play the integer game with your group without using a number line. And I'm not sure if... I'm not sure if you've been working with a number line when you've been playing the integer game. I haven't actually expressed whether I wanted you to or not, I don't think. But anyway, if you want to, go ahead and play some integer game. The whole idea is for you to go play integer game without the number line, come back, and we could share what concepts you guys used, if anybody used for example, the additive inverse. Okay, and remember what the additive inverse was. It's like 2 and negative 2. Yeah, those two together. They are the additive inverse, and whenever you sum the additive inverse of a number, you get 0. Okay, which makes sense, right? Okay. Yeah, and again here down the end, example 1. Counting on to express the sum as absolute value on a number line. I'm over here looking at this one. A model that we've seen. It shows the two different ways to do it. The whole counting up right here. Remember, doing the hops, single unit hops. Okay, here we go. We have our first our first addend, I guess we call it an addend. You ever heard of addend? It's the first thing we're adding, the first number where you're going to add. So our first addend here, is 2 right here, and it is shown here with the vector shooting up to the right 2 places, and then over here 2 hops. Okay, and now we are adding another number, and this is confusing to me. They have this in red, but anyway, they just wanted to distinguish between the 2 numbers. I guess could have picked a different color, but so we have 4. We're adding 4, so we're going to continue on the right another 4 places, and these are the hops, and this is the vector arrow, and we end up at 6, which is right here. Okay, and again here we have now counting down. We start with our first addend here, which is the 2. Okay, expressed these 2 different ways, and then we are adding a negative 4, which means we're going to go to the left 4, and that's expressed with this arrow going to the left 4 units, and also for the 4 hops, and you can see where that ends at negative 2, which is what's happening there. So, the point here they're making is, counting up negative 4 is the same as the opposite of counting up 4, and also means counting down 4. Okay, so this idea of counting up negative 4, okay, is just the same thing as counting down. That sounds very confusing to me, but ignore that if that confuses you. Okay, so here are some questions here. Some questions they ask you here. So question A asks you, for each example above, what is the distance between 2 and the sum? Actually, why don't we do this? I don't want to do that yet. I want to just show you something, because here is something they wanted me to show you. Just a different way using vertically oriented number lines. Okay, and you can see this number line is not very typical. Okay, we usually spend most of our days working with horizontal number lines. Okay, but this one here is vertical. So what I wanted to do is just to show these two problems using a vertical number line. So this counting up here, again we're moving up, and what I like about That's our first addend right here, the 2. What I like about this vertical number line, even though it is a little bit cumbersome, it's not as, I don't know why, it just wouldn't be as easy to work with, but I mean, it shows you a real life example here. We don't usually see real life examples of the horizontal number line, which looks like that. But here we do, because this looks a lot like, to me, it looks a lot like a thermometer. Okay, if you imagine a thermometer, that's really, boy, that's not working out. Let's just do it again, thermometer, okay? And again, this is not thermometer. I just don't, I'm not, again, I don't want to confuse you with this, but just the idea of, this looks a heck of a lot like a thermometer, as you would see if you're going to take your temperature, or take the temperature of some water. We've all used thermometers. But anyway, back to our problem here. So our first addend was the 2, and then we are adding and counting up another 4. Okay, so there's our 2, there's our 4, and here is where we end up at 6. Okay, let's see, and the counting down. And again, there's going to be a question about this thing, so just so you know, you have some experience with it. If we went ahead and did the other problem, we had 2 plus negative 4. Oopsie, this is 14. Negative 4. Okay, equals negative 2. Okay, and so we had our 2. We went up 2. Okay, from there we went down 4. Okay, so we end up right there. So this is negative 4. This is a positive 2, and we end up here at negative 2. Okay. Alrighty. So again, just flipping it over to look at it vertically. Again, like I said, makes a lot more sense to me, but you won't see that very often. Okay. So let's go ahead and now look at those questions, because I think one of them refers to this vertical, the vertical number line. So anyway, for each example above, and what they mean are these here. So if you go back and take a look at those, let me just clean this up, just so we can look at this a little bit better. Okay, a little bit more clear. All right. So it says, for each example above, what is the distance between 2 and the sum? Okay, so now here is the very interesting thing, and this is really what they're driving at here, is this piece of interesting information. So if we look at 2, okay, and we find 2, bird in my backyard here, we find the number 2, and that's right here, okay, and here is the sum, okay, because there's 2 and here's the sum, and you'll notice the distance, and again, distance, remember that distance should key you into a certain term we've been using, but it's 4. You can see, look at, we have 1, 2, 3, 4. Okay, so 4 units. Okay, from the number 2 to our final sum is 4 units. Now, if you look at this one, let's find number 2. Here's 2. Okay, and we find our final sum, which is actually negative 2, and we go 1, 2, 3, 4, and again, it is 4 units. Okay, I think, very, very interesting. So the distance for both of them, they're both 4 units. From the number 2 to the sum is 4 units. Okay, so next question, does the sum lie to the right or left of 2 on the horizontal number line? Okay, does the sum lie to the right or left of 2 on the horizontal number line? Well, on the first model, of course, we take a look. First model here, the sum is on this side. Okay, it's on the right. On the next model, you can see the sum ends up on the left. Okay, and so vertical. So we go to vertical. We can actually do this on a vertical number line here. You can see for this one, this is the second one, the sum ends up on at the bottom. Okay, at the bottom. All right, but then if we did this one, we could just do this other one over here in green. Remember we did 2, and then another 4. Okay, that was 2, 4. So you can see that the sum ends up on the top of the number line. Seems pretty basic, doesn't it? It probably is. Okay, and then you could write it in there. I hope you've written it in there yourself. Model 1, sum to the right and at the top. Model 2 to the left and at the bottom. Okay? Alrighty, so now C asks, it says here, given the expression 54 plus 81, determine, without finding the sum, the distance between 54 and the sum. Okay? So go ahead and think about that. Probably really, really simple for some of you, but maybe some of you find it a little tricky. I don't know. But go ahead, and I'm going to pause here, and then you go ahead and see what you can do with this, and then come on back. Okay, yeah, again, so the distance between 54 and the sum, well, that distance happens to be the 81, right? Okay, because you have your 54, you're going to go 81 units to the right because you are, it's a positive number, and then between 54 and that final number, of course, here 54 and to 81, that's all of this in between. Okay, I'm sorry, 54 to the sum, the final sum. Okay, that's going to be 81, distance of 81 units, whatever those units are. Okay? All right, so again, yeah, 81 is the answer to that question. And you probably got that. So here's D. So D, so continuing on this example here of 54 plus 81, is the sum to the right or left of 54 on the horizontal number line. Okay, and of course you know it is to the right. Okay, because you are adding. It goes like this. Remember, it's 54 plus 81. Again, we're not even talking about the sum right now. We're not even interested in that. It's to the right because we are adding. Okay, so there you go. And then above or below on a vertical number line, of course, is going to be above because we are moving upwards into positive territory on a vertical number line. All right. Here's a new expression here. We have an expression is 14 plus a negative 3, and determine, without finding the sum, the distance between 14 and the sum, and then just tell me why, and I'll pause here, and please try to come up with a pretty decent explanation if you can. Okay, well, hopefully you're understanding this now and getting this. So if we have this given expression here, 14 plus a negative 3, the distance between 14 and the sum, of course, is going to be 3. Okay, it's going to be 3 units. Just put 3. I guess it's 3 or 3 units, and why? And why would that be? Okay, well, I mean, you know you're going to be at 14. Okay, you're at 14. The only thing you're doing here, and again, we're always remembering now, whether this be negative or it be positive, its distance from the place where it starts is always going to be the same. Okay, So we're at 14 here on the number line. We are going to move 3 this direction, 1, 2, 3, and that is the negative direction, okay, negative 3. We are still moving 3 units, okay? Now even if we added 3, we would still be adding, we would still be moving, our distance would still be 3 units, okay? So this second addend, okay, it doesn't matter if it's positive or negative, because we are looking at, remember what we called this the absolute value, okay? So we look at that negative 3, and the absolute value of that number, okay, is 3, okay? So yes, the answer there is 3 units, okay? And yeah, so here we go. Is the sum to the right or the left of the 14 on the number line? Okay, and again, that negative, since that is our second addend, we're moving in the negative direction or to the left, okay? It'll be to the left of 14, okay? Because as we saw right up here, number 14 is there. We are going negative 3, and we are going to be to the left of 14. Okay, we're not really worried about what that sum is, but many of you know that would be 11. Okay, on a vertical number line, of course, it's going to be below the 14. Okay, because you are moving in a negative direction, and that whole idea of this negative right here, it just tells you about direction. Okay. Direction. Negative is going to mean either down or left, and then positive is going to be just the opposite, up or to the right. Okay, here's exercise 2. I ask you to work with a partner to create a horizontal number line model to represent each of the following expressions. Describe the sum using distance from the p-value, okay, and this p-value, let me just explain that. Throw a lot of things at you here, okay. This p-value is your first addend, okay, and they look at p and q, okay, and that would be this. So here's your p-value, okay. And the other one is called is a Q value. Okay, Q value is your second addend. And if you want to write this down, this is not in the terminology. Probably need to get that there at some point. But yeah, so the P value. Okay, so let's just read this whole problem again. So work with a partner. Again, your parent teacher or a sibling or a friend, to create, or do it yourself, to create a horizontal number line model to represent each of the following expressions. Okay, and there are going to be a few here. So here's A. Describe the sum using distance from the p-value. So what they want you to do is describe the sum, how it relates in terms of the distance from the p-value or the distance from the first addend. Okay. So let me go ahead. There's going to be hold on a second, there are a couple of these. There are a few of these, right? Okay, let me just go ahead. Let's just do this one right now together, okay? So here we go. We have negative 5, okay, and negative 5, again, we're going to start at the 0, okay? We're going to go to negative 5. I'm going to use the vector, the arrow, vector arrows, okay? So we have negative 5, okay, that's our p-value, okay? P-value negative 5, and then we are going to add 3, okay, because we have, we're going to sum 3, then we're going to go 3, of course, and as it is, there's a positive, there's a plus sign here, and there is no negative sign. We're going to go to the right, 3, 1, 2, 3, right there, and we end up at negative 2, okay, so negative 5 plus 3 leaves us with negative 2. Okay. Now, if we describe the sum using distance from the p-value, okay, the sum is -2. That's right here. Our p-value, which is our first addend, is a -5. And what we see there is we have a distance of 3 units, okay? So a distance of 3 units between p-value, and again, just getting used to this p-value, this idea, this maybe we'll call it primary value. I'm sure it means something. I'm not quite sure right now, but between p-value and the sum. Okay? All right, so the answer to this one would have been, what you're going to do for the rest of them is you're going to go ahead and do this work, and then you're going to give a distance in units between the p-value, well, whatever they ask you for. Okay, I'm not quite sure. All right, so go ahead, I'm going to pause, and then if you would go ahead and do the rest of these. Let me see what we have left here. We have B, C, I think just B and C. Okay, so 2 more. Go ahead and do those and come on back. Okay, welcome back. Let's go ahead and do this together. I'm gonna do it again with my vector arrows. Okay, so my p-value here is -6. It's my first addend, so I'm going to go ahead and draw that in. Take this to -6. Okay, and then I'm going to add a -2. Okay, add a -2, which is the sum of those. So a -2, I know I'm going to continue to the left. And there I am, and I stop at -8. Okay, and now again, that question was, so what was it? How, I guess these are all the same. Describe the sum using distance from the p-value. Okay, so now we have our p-value, which is right here, which is -6. That was our first addend. And then our sum right here. Okay, and so the distance here is 2 units. Okay, all right, and again, we're explaining why. Why it's 2 units. We know, whoops, just like we said before, the first addend, the distance of 3 units between p-value and sum, and here we have the distance of 2 units between p-value, which is right here, and the sum. Okay, and you can see what happens is that this 2 units, this distance here, this absolute value correlates to here, to that -2, and in this case, to that 3. It doesn't matter that that is a +3 and that is a -2. The units are the same because the units that we're talking about, this distance, is always positive in terms of absolute value. Okay, again, if you remember that ant crawling along these number lines, you know, it doesn't matter which way that ant is going, towards the left or towards the right, they're still moving the same distance. Okay, again, real important thing, real important concept again as you move into to 8th grade science. So hopefully some of this will ring a bell when you encounter it next year. Okay, so let's do that next one. I'm going to turn to green pen because I'm sick of this black. So anyway, here we go, 7. It's my p-value. Start at 0, go to 7. Okay, that's my p-value there, 7. And now we have a plus -8. Okay, so that negative is going to tell us we are going to move to the right. We'll go ahead and do that, but now we're going 8 units to the right, and that leaves us off right there at -1. Okay, p-value, our first addend, sum right there, and now the distance between these two, yes, you guessed it, 8 units. Okay, 8 units, which corresponds to that -8 right there. Okay, alrighty. Hopefully everyone's getting this, and again, I think it's a lot of fun. I mean, it's fun because it's not all that like formula heavy, but knowing this will be more important than you can ever imagine. Okay, and I know for some of you this seems silly, and you're already 25 minutes into this lesson, and you're thinking, when is this going to get hard? Well, just remember all these terms that I'm using. Absolute value, a p-value, okay? All of these things, q-value, okay? All of these are really, really important to remember as well. All right? Here we go, exercise 3, writing an equation using verbal descriptions. Okay, so here we are. We're going to turn these words that they're going to give us here. And again, if you need to know what these terms mean in order to write an equation from them. So here's what I'm going to do. I'm going to let you go ahead and do that. Why don't you go ahead and pause, and I'll just read this here. Write an equation using the number line. Create an arrow diagram given the following information. Okay, so you're going to write an equation here, and then you're going to use your arrow diagram on the number line for this information. The p-value is 6, and the sum lies 15 units to the left of the p-value. Okay? Use that information to create an equation and to make an arrow diagram on the above the number line. Okay, so go ahead, pause, do that, and just do what it tells you, and I think you'll know how to do it. Okay, so if we just plug in for this equation as we go, so the p-value is 6, so I know that's my first addend. Okay. Because I know that because I learned that in this lesson, and hopefully you have learned that in this lesson. Okay, 6. And the sum, and of course we're always talking about sum, so we know we're going to be plus, okay, lies 15 units to the left. So here we go. Let's just circle a few very important things. P-value is 6. So that gives us our first addend. Sum, of course, always tells us that that's going to be a plus sign there. Okay. 15 units to the left. So if I'm going to the left 15 units, that is going to be a negative 15. Okay. Negative 15 right there. Now that's an expression. Okay. 6 plus negative 15. To make that an equation, and you might remember, making an equation, we need an equal sign. Okay, and so we need to know what the answer is. So let's go ahead and do our line, do our arrow diagram down here. So we had 6. We start from 0, go to 6. That's our p-value. And then I'm going to change to red. Then we went to the left, or we summed or added a negative 15. So then we're going to start the 6, and we're going to go negative 15 units to the left, okay, just like they told us to do, and we end up at negative 9. So therefore I will go ahead and put, I don't really need this, but I'm going to put it anyway because I like having the parentheses. Okay? And there we go. 6, because I had a p-value of 6, plus, because we're doing sum, 15 units to the left equals negative 9. And I'd love to know how many of you did that perfectly. Maybe you could brag about it and tell me when I see you again. Okay, so let's go ahead and just before we summarize, just a few points. Okay, one question before we get to our lesson summary page. What role does the absolute value of negative 16 equals 16 play in modeling the expression 2 plus negative 16? Okay, so what role does knowing this, okay, what role does knowing that play in modeling that expression. Okay, and if you want to pause now, you can, or we could just talk about it. The main point here is that it will tell you, okay, always that your this absolute value of the Q value, okay, that second addend, always represents the distance between that first addend and the sum. Okay, so you have the first addend, which is that P value, and then you have a sum, okay, over here. That distance is always going to be this Q value, okay? And Q value, not the Q value necessarily negative 16, but of course the absolute value of that Q value, which is always the positive. Okay? All right, so let's go ahead and summarize. I have a summary page somewhere here. Somewhere. I think I lost it. Okay, might have lost it. Let me go find it. Okay, well here it is. So in summary, a few things to remember and to note. Addition of integers is represented on a number line as counting up. We're counting up a negative number of times is the same as counting down. Now, I don't know if that is confusing or not, but the idea is that this idea of counting up, what I think they're trying to say is that we're talking about sum, we're talking about adding, okay? Adding, all right? And then we're counting and everything, and counting down is subtracting in that sense, okay? So if you're counting up a negative number of times, which sounds very strange, okay, you are actually adding, but you are moving in the opposite direction. You are counting down. Now, why they are emphasizing that is not very clear to me yet, but maybe we will see that in the future, and maybe we'll have to refer back to this, okay? Again, this point right here, the arrows show the sum of two integers on a number line. Using those arrows or using those vectors, okay, is a good way to experience integers, negative and positive integers, until you really get a full, firm grasp of it. Okay, and that last, probably a more interesting or more crucial point here is the sum is the distance Q from the P value, the first addend, to the right, if Q is positive, right, positive, and to the left, if Q is negative, okay? And it all makes a lot of sense just knowing that they're using these terms, p-value, Q. P-value, of course, is just that first addend, okay, that first number you're adding, and then Q is the second addend, okay? And that Q is always going to represent that distance, okay, the distance from the first addend to your sum, okay? Alrighty, and yeah, well that is it, and go ahead, do your problem set, exit ticket, and come back soon.